Hello, everybody out there. Thank you for joining. We'll give everybody a moment to arrive here. So hopefully you're all safe and hopefully working from home, virus free where we're at. It's raining right now, so hopefully it is rain free where you're at as well. And if you're watching this after the fact, thank you for taking the time to watch this remotely. So we'll get started here and then we'll turn this over to TG. So first of all, this is the May installment of the PASS HADR virtual chapter meeting. So again, thank you all. We're going to start with a little bit of PASS community news. So first of all, PASS Summit 2012. There are some spotlights out there. Just go check it out. It is a fantastic event. I've been a part of PASS Summit for a long time. The virtual chapter here does have a registration code for you. You can save $150 on registration. Go check it out. They have not yet released if they're going to be physical or virtual. Either way, it's a great show. No matter what, sign up for it. It's awesome. You can, in fact, win a 3-day registration pass. So at the link down below there, you have until June 9th to sign up for it. It's a good survey. What do you want to see out of it? How would attending this make your life better, your career, your organization, all those sort of things? There's a ton of really good content out there. There's a best of PES Summit 2019 out there. Go check this out. I make it a point to get the recordings every single year. I watch the recordings from years past constantly because there's such good content. So go check it out. It's a really good way to say, this is really worth it. We need to go. There is a webinar coming up the next couple of days with Dell EMC Power Store for SQL Server 2019. So don't want to mark it for anybody, but it should be a pretty good event. So go check that out. We are not the only virtual group out there. The cloud group is amazing. They've got stuff almost every single week. It's a bunch listed. If you just go to the PASS virtual group site, you'll be able to see them. There's pretty much every single day at this point. There's just really good content from all over the place. Like I said, we're not the only virtual group. There are approximately 20 virtual groups at this point. There's tons of great content out there. If you can't watch them monthly when they're presenting, these are recorded. They are available online afterwards. So go check it out. There are virtual SQL Saturdays thanks to COVID-19. There's a couple coming up here at the end of the month. Go check it out. If you're a speaker, go sign up. Most of these are going to be virtual, at least for the next couple of months. So go check this out. If you are looking for a new career or recruiting for good technical talent, PASS does have a career center. There's tons of really good information out there, both if you're looking for a job and for folks like me that might be interested in hiring you. So go check it out. If you are not a member of PASS, well, hopefully you are by listening into this. You can sign up for a free membership out at pass.org. All the usual social media channels, go check it out. The biggest thing for me is PASS TV because there's tons of really good free content out there. So we're going to turn this over to Thomas Grozer. And if those of you are not familiar with him, this guy is a legend. I'll let you introduce yourself, but I can tell you it is an absolute joy to have worked with him and to have gotten to know him pretty well.
Okay, hello everybody. I'm gonna turn off my camera to save bandwidth and make the presentation as smoothly as possible. I hope everybody can see the screen, and let's get started. So this is not SQL Saturday, as you might have noticed. This is the virtual chapter for high availability and disaster recovery, and we're gonna talk today about, so we finally managed to get an SLA, and we will quickly, briefly touch how to get there in a good way. And so now what we have to do is to actually translate that into matching this SLA. And one of the big learnings I hope everybody gets out to it is don't overpromise, because that will in the end backfire. So few quick words about me. So you can run this query, select from me where topic is SQL Server. It will give you my name. I work for a company called Entity Data, and we're consulting, and I'm always available for hire. I'm with SQL Server forever. I started in 1994 when 16 bits were top of the line. and I tortured and pushed SQL to the limits ever since. And I contributed to a couple of publications, and big part of my job is to yell at Microsoft so that they make SQL Server better. And for the last 10 years, I've been awarded the Microsoft MVP for first SQL Server, now all of Data Platform. So yeah, that's me. Moving on. 26 years with SQL Server and counting. So, service level agreement. What should be in it? It's the very basics, and I have a whole 1 hour talk about what should be in an SLA in detail. It's available on multiple past websites. And it's the bare minimum that needs to be in an SLA is the recovery point objective. How much data can we lose? A lot, couple of days, none. Very wide range of possible answers to that question. The second one, the recovery time objective. How fast did we need to recover? If something goes wrong, how fast do we need to be back? And that's usually the main thing everybody is focusing around. The third one is that usually should be in there. How fast do we need to be? Yeah? One query per day, 1 per second, 1,000 per second, 1,000,000 per second. What is needed to satisfy the business so nobody yells at us as a DBA? And the last part is it should have basic security, especially the big question, what's more important? If we lose data, and with losing data, I mean someone steals it, is it more important that they cannot get to it? Or is it more important that we can recover the data? Yeah, so talking about self-destructing data. So what's in it? That's where everything is, and much, much more. Your SLA, this is your contract with your managers, with your business, and contracts are here to protect you. Contracts are not here to do it. So I worked with companies where we were literally get paid by maintaining the SLA. So our bonus was tied to, can we match the SLA, yes or no? If no, it cost us a big chunk of our bonus. The most important thing you have to understand is that availability is not just a recovery time objective. While most people treat it like this, it's like, okay, how fast can we come back? And no, it's not. Availability is recovery time, recovery point, performance, and security. Like I can bring SQL Server back super fast and I give you an empty database. If it's availability is just RTO, that's perfectly fine. There's no more data. Yeah, but you didn't ask for it. So in the SLA, so you're getting an empty database. Keep going from there. You get the idea. The same thing is the system available? When yes, I can connect, I can run a query, but instead of the usual 5 seconds, it currently takes 3 hours to complete. Yeah, not the case. Or yeah, the system is online, but instead of just our application, now the whole world can access the data. It's probably not considered available the way it should be. So availability is the whole thing must be running. And this is how I usually approach it, because just having a part of it doesn't make any sense. Yeah. Achieving availability is super easy. There's no, it's not hard. Yeah. Guaranteeing availability is super, super hard. Yeah. Having a lucky year where you have 99.99% availability happens all the time. I have cases where I had 100% availability in a year. Yeah. For the whole fleet. Not a single machine ever gave up in a whole year. Yeah. Could I ever guarantee that that is the case? No, no way in any universe that would be possible. Yeah? So guaranteeing, there's a big difference between what you can achieve with luck and what you can actually achieve by guaranteeing it. It's very different. Lots of people confuse the luck part with what actually availability needs to be. Yeah? Getting lucky, super easy, and most years you will be lucky. But then one year it might hit you, and that might cost you your job if you're not prepared for it. So first of all, the SLA has to define availability. And every time I read this, any one of them, I'm like, why? No, this is not a definition what availability means. This is sad. Yeah. Especially the 5 nines. Yeah, because as we will see during the talk, achieving 5 nines is close to impossible. Yes, yeah. So what I want to see in an SLA is something like this. The system must be able to complete more than 95% of transactions within one standard deviation of the median execution time between Sunday 11 a.m. and Friday 11 p.m. Eastern Time. And this is from a real case. This was our SLA. So translated into more English is 95% of all the transactions that we run against the system, each one of them, because they run against the system over and over and over again, each one of them has an average time, how long it takes to run. Yeah. And so you have the execution time of that thing. It has some average, which is somewhere in the middle, hopefully. And then you have plus one standard deviation and all the way down. Nobody has ever complained if something runs way faster. So the minimum is at the beginning of like 0 time. And everything between minimum and average plus one standard deviation is fine. So percentage wise, this is usually your average plus minus 30%, 40%, depending how it is running. And this depends. Yeah? If you run a query one time with a parameter that gives you 10 rows and the next time you run it with 1,000,000 rows, that standard deviation will be much wider. And this is why it's formulated like this. Yeah? For a query that runs all the time with the exact same kind of parameter and always returns like 10 rows, yeah, that standard deviation will be like close to nothing. Yeah? And then it has to be much, much more accurate. But this is a definition I can live with. This is something I can actually execute. And everything that takes longer is outside the SLA. And as long as it's only 4.999%, I'm still within SLA. So 5% of the queries can still be taking longer, but not. And this is over the whole year. So that's one way. Another example, same thing. That's a real practical example from the world out there. The system is considered available if in a specific minute. So what they did is, after running transactions all day, they looked at the data warehouse. At the end of the day, they looked at the data warehouse, and there was a table called customer account details. And every time a customer played any game on the website and needed to pay money to do so, there was an entry in that table. Yeah. And the definition was, if there's one or more entries per game in that table with a timestamp in that minute for that game is considered available. If there's none, then it was considered offline. And that had to be the case for the 98% of the most popular games. The problem is, if you have a game that nobody plays, it will not have any entries, but not because it's not working, because it's so bad nobody wants to play it. So these were excluded. Again, as same as before, you can't guarantee 100% of something. That will never be the case. Here it was, yeah, we give you 2% freebies. Nobody plays that game, that's fine. Yeah? And on some days when all the games were played, that gave us 2% of failure rate that were possible have. Yeah? And they had the other thing that no transaction can be lost. This is something you can work with. This is something you can actually engineer a solution against. Yeah? If you just have some random number, we need 99.99% availability. No, you don't. Not all day long, not in all areas. There has to be some wiggle room to do something. Yeah? And to put that into perspective, we had about 400,000 entries in the table per second during peak time and 30,000 per second in off-peak times. So this was not left to chance. Normally there were hundreds and thousands of entries in each one of these categories. So how to check availability? So now we've defined it. So how can we check it? Yeah. So first thing that comes into mind, and God, I miss the times when we presented in rooms and we could get feedback from people. because that would be a question and people would yell out monitoring. So I have to do it now, monitoring. Yeah. So monitoring is great, but how often does it probe? Every 5 minutes? That's usually the default of all the third-party monitoring software. And most of them let you tweak it down to 1 minute. That means it tests once a minute or once every 5 minutes. That's a long period of time. Yeah. If you guarantee 5 nines, so 99.999%, my magic number that I hate so much, that gives you only like 5 seconds of downtime per day. So, and you're checking every 5 minutes. So what happens in between? If the system just like in 5 minutes, I literally can reboot the server and be back online. And you would never know because I wait for the monitoring to come in, reboot the server, the next monitoring probe comes in, and the server is just back online, especially if it's one of David's virtual environments that he builds that are awesome. So, second one is, and I just put it in for jigs and giggles, you can guess it. And because that is as good as monitoring for when it comes to availability. Don't get me wrong, monitoring has its use case, and if you might get some useful, but for checking availability, monitoring is just don't go there. And of course, guessing is not an option. Yeah? The two things I've learned over the years that works is one is application logs. Basically, every time the application accesses the database, it writes an entry into a log, and then afterwards you analyze these logs for how long it took, what happened, what thing is. Yeah? This is what the first company we did, where the definition was based on the median and standard deviation that all came out of the application log. So the application wrote that to some text file. These text files were read in and then processed in the database, and we figured out what was going on there. And the second one, if this is not available, because it's a lot of effort to put that in your software, but it's not that much of an effort. You have to put it in your data access layer, and then it works for everything. And the second one is you can analyze the transactions that are in your database to figure out if it was working all the time. Yeah. And of course, if you have none of these, monitoring is still an option, better than nothing. But I would not tie my salary to the results of monitoring software, because most hilariously, all the monitoring packages I know have no concept of high availability and DR. So they will completely report that stuff is offline while it's actually perfectly fine on the DR side. So moving on, failure modes. What can go wrong? Yeah, a lot of things can go wrong, but I have kind of a group of categories. Yeah, some hardware component fails, a disk, network card, something inside your server fails, feels unhappy. Thing is, yeah? Second group is the whole device fails, the whole server, or the OS crashes, server switch, storage array, completely the whole thing goes away. The third one is all the things in the data center go away because the data center loses power, or someone, a caterpillar hacks through the fiber optic lines that connected with the world, all stuff that happened. And then there's my favorite category, human errors, drop table, delete update without aware clause, all these nice little things. Some software that made a mistake and put the wrong data in. Data gets loaded twice and we don't have unique constraints, stuff like this. Plenty of things to mess up, like the missing bracket at the end of the slide. The next one, theft and sabotage. Your competition is literally sending an evil person to steal your data or to mess with your data center. Easily possible. Data centers are not as secure as you might think. And my favorite that happened to me in one company, a coordinated multi-government strike against your company. So 7 governments came together and decided they will send SWAT teams into all our data centers. Unfortunately, lucky for us, it was only 7, and we had 8 data centers in one more country they didn't know about. So all the site did quickly struggled, and about 30 seconds later, everything was back to normal, and they were standing and wondering what happened to them. The company won all the lawsuits against all 7 countries, and I think it's never going to pay taxes again. Choice of hardware. So, and this is where the controversy comes in, and usually if there's hardware vendors, they will leave the room in a few seconds. So I'm going to watch the number of attendees. If it goes down, I know a hardware vendor is listening in. Choice of hardware. We have two choices: fast and cheap hardware or slow and expensive. Sounds a little bit not correct, but in these days, these are your two choices. And with fast and cheap hardware, you buy a redundancy with many servers. Yeah? So you don't have redundancy inside the server, but you just have another one right next to it. This is what the clouds do. All the servers that are used in the cloud are like at the very low end. Yeah? They might not even have a second network card. They're just like one power supply, anything. Something happens, you spin up a new machine, you transfer the servers, everybody's happy again. Yeah? This is how this works. Slow and expensive, you build redundancy with many expensive and slow servers. That's the difference. Yeah? And I will prove my statement. Don't run away yet. Thing is, the difference is for databases. That's not so much true when you go to web servers or so. Yeah, there's less of a difference. But for database servers, it's very different. These days, you can build super fast I/O by using NVMe drives versus the more traditional SAN networks attached storage that is slow and expensive versus NVMe drives are super fast and super cheap. Yeah? So on a fast and cheap server, the maximum current physical speed you can build is 240 gigabytes per second write speed on your drives. Yeah? That means a terabyte every 4 seconds. Yeah? And the low end is in the 15 to 70 gigabytes per second. Yeah, that's the machines you normally would buy. Yeah, which is still insane if you compare that to the fastest all-flash arrays. You can write with about 2 gigabytes. Some of them now hit 3 gigabytes per second, but the vast majority of them is somewhere at 1 gigabyte per second. That means it takes 1,000 seconds to write a terabyte versus 4 seconds on the direct attached storage. Yeah? So there's a gigantic performance difference between these two systems. Yeah? So what's the difference? The difference is with fast and cheap, I have the box, I have my CPU, I have my IO cards, network, whatever, and then I have the storage. Yes, storage is still symbolized with a floppy disk, and it's getting harder and harder because, believe it or not, there's people out there that have never seen a floppy disk in their life. And the slow and expensive have the same CPU. They usually have redundant network cards, redundant IO cards, and then they have redundant storage outside and have a redundant way of connecting it to the server. And this is what's expensive. You need a separate network for the storage. You need that extra storage device. They want licensing for everything. You need to double the storage and everything. That adds up. Yeah. And usually the price of these machines is at least 2 to 3 times more expensive than fast and cheap, as I call it. Yeah? And the reason is not because that second network card, that's $100, the cost is here, that storage array. The bigger they are, the more they cost. And they usually can only service a handful of servers. Yeah? They can be shared, but it's not that easy. So the fast and the cheap servers, both of them will fail on average about once a year. Something in the server will fail, a disk, a network card, something we discussed, yeah? Or the whole thing, yeah? Or the OS crashes, something like this. One failure per year, and on the fast and cheap server, I immediately agree it will take us 3 days to fix it because it's broken. Someone has physically go there and replace it, replace the part. That takes usually on average about 3 days. Yeah? And that gives us about 99% availability of just that hardware. That doesn't take into account any SQL Server software and anything on top of it. It's just the raw hardware. It's 99%. Okay, that's a number. Let's park it there. The machine that has everything built in redundant also fails once per year, but whatever fails doesn't immediately stop the machine. If one of these disks fails, it still works. If this thing fails, it still works. Yeah? There's no, the whole thing ran. So the 3 days to fix it, we still need 3 days to fix it, but in the 3 days, it keeps running. It runs in a degraded state, but it keeps running. And then when we fix it, it will take about 4 hours. You have to shut it down, pull the thing out, pull the other thing in. Some of the components can be swapped out while it's running, but again, I like to be on the negative side and only have, like, I'm a pessimist, so I always get surprised in a positive way. I assume the worst case scenario. So this gives us 99.95% availability for that single server. Yeah. I think it's, yeah. There's way more complex ways of calculating this. I've tried them all over the years. This is purely based on, I managed a couple of 10,000 servers over 30 years, and this is how often on average they fail. Yeah? And this is how long it usually took us to fix it. Sometimes it takes 6 days, sometimes it takes 20 minutes. Yeah? Because the spare part is there, someone's right in the data center, you give them a call, they swap it out, everything's fine 20 minutes later. Sometimes it takes 6 days because the delivery company messes it up, and or the vendor sends you the wrong part, whatever. Yeah? So average. So what's on top of that? That's the pure hardware. Yeah? On common downtime of that for every hardware that you have to think of is usually patching, which in my case, it's roughly 12 times a year, and it takes down the systems about 2 hours each. Yeah? That's about 1 day of downtime per year. And that's planned. That happens at a time when everybody understands the systems are not running. That's not like you're doing in the middle of a trading day when you're a financial company, or you do it right in the middle of a sports game if you're a sports betting company. Yeah, no, this you do it at 3 a.m. in the morning on a weekend when nobody needs the system. Yeah. So the other one is maintenance. That's not so much independent between each server, because maintenance on the fast and cheap, I'll do it once a week, so 52 weeks a year, and it takes about 2 hours, so 104 hours. On the slow and expensive machines, same 52 times a year, but it usually takes about 4 hours, because things like index rebuilds or so take much longer on these machines. And yes, there's online index rebuilds, but they're not that online, and they still disrupt the system, and not all types of index can be rebuilt online, blah, 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 blah. Yeah? So roughly maintenance takes twice as long. Yeah? And that's okay. So if we now take the 72 hours failure versus the 4 hours we have for failure, add it to the 104 and 288 hours, plus add the 24 hours of patching that we have for both systems, we end with that the cheap systems are down for about 200 hours a year, versus the expensive systems are down for 236 hours. And again, you can argue that the maintenance doesn't take 208 hours, whatever. Yeah. The bottom line is, a faster, simpler machine can be overall as available as a more expensive one. The difference is, if the fast and cheap machine fails, it's a massive outage, versus when the slow and expensive machine fails, it's a small, more controllable outage. Nevertheless, I stopped using slow and expensive machines about 15 years ago, because it just, from a financial perspective, not worth it. They cost 4 times as much, and they're not that much better. Yeah? So 99.7 versus 97.3, so 97.7. So technically the fast and cheap is better. It always depends if you look at it as the overall availability versus just planned and unplanned. When it's just planned and unplanned, the slow and expensive outbeats the other one by far. Yeah? But if you take the whole picture, they are much more similar, and definitely not worth paying 4 times as much for it. Common downtime for software, that on top of it. So SQL Server will also fail, and databases will fail, and other stuff. Yeah? So if we need to restore a database, to restore full, it can take, you can do somewhere between 1/4 of a terabyte and 120 terabytes per hour. That's practical thing. That's through the network coming in somehow. That's the slowest machine I've found in my environment, and that's the other one is the fastest machine. Yeah, differential backups and restores about the same, and log backups I find run with about half the speed, because a transactional log backup has to do much more than a full backup when you restore it. So they usually run at about half speed. That's, again, experience in my environment. Every environment is different, and the numbers can change. And then you have recovery at the end, because once you restore the database, you have to recover it, and that can take seconds to days. My personal record is 26 hours. that I've had to watch a database recover, but I've heard from lots of people where it took more than multiple days. And the second one is if we build high availability, we have failover time. How much does it take? The detection takes seconds, usually 5–10 seconds, and they know something's wrong. We have to failover. Then the actual engine failover takes seconds, usually 3 to 7 seconds for the engine to actually failover to the other node. Yeah. Then the network, if it's on the same subnet, is within the seconds of the engine failover. But if it's a multi-subnet and you have to fail over into different data center, it can take up to a minute for the network to rearrange and find that SQL Server again. Yeah. And then recovery, again, same as with restoring a database, somewhere between seconds and days. So this on top gives us the idea that we have some availability based on the hardware, and then we have some availability based on the software on top, because SQL Server will fail. How many times a year depends on what you're touching it. But let's say again, once a month, there's some reason to fail over. Might it be patching, or might it be something else is wrong, some network glitch causes a failover. Yeah, that is, that will, depending on how long recovery take, lower your SLA. So let's go to the exercise, how we can build up availability. And in the first round, we're just looking at adding hardware. Yeah? How does availability change if you add a second server, a third server, and which roles do we have to give them? What are the cases? So first we have a primary server where everything starts. And before that, we figured out that they have 97.7% availability just from the hardware. Thing is, if you have a single server, you basically have no availability, because if that thing explodes or the data center explodes and you don't have any backups, all your data is gone, so you can never recover, and therefore you have infinite downtime and therefore technically zero availability. But let's jump over that. And thing is, so you add a DR server. Yeah, okay, so you have two. You somehow move the data to the DR side. We haven't specified how we do this yet, but you have a copy of the data on the DR side. So if one data center blows up, or one machine in one of the data center blows up, the other one can take over. You lose some data because they are not like next to each other, and that's why they have different colors. So that means if the data disks are orange, it means it's slightly behind. Yeah, so that will get you, just from adding another piece of hardware, to 99.94. And this is why I say using two cheap servers is much more effective than one expensive one. The one expensive one costs about 4 times as much. Two cheap ones, price of two, gets you to 99.94 immediately. That's way better. Thing is, you have two copies of the data. In the expensive one, you also have two copies, but they are in the same machine, they're in the same device. What if that device fails? That software in there, what if that software fails? So the next one, you say, hey, I want to make sure that I have a synchronous copy of the data, a second copy that is like up to date. So I need to send the data to the primary machine and the second machine, a high availability machine right next to it. And then we still keep the DR copy. That will get it to 99.9988%. Yeah? So that's pretty good. We're talking now like less than a minute of failure just from the hardware, because one of them fails, we fail over to the other one, it keeps running, no things. Yeah? If the whole data center fails, we fail over to the DR site, we lose some data, but we are up and running quickly. And many businesses can tolerate a couple of minutes of lost data. They can rerun the last batches. The web servers might still have cached information and be able to write that transaction again. Many ways where this could be just fine. If it's not fine that you have data loss on your DR side, you might have to add a third data center that I call the higher availability data center, where you put another machine, which gets you to 99.9997 theoretical availability. And this is very theoretical, because at that numbers, you cannot detect that one of them has failed. Yeah? So as we're going to play with that number because it's fun, practically, no, it's not going up anywhere, because it still takes like a minute to figure out something's wrong. And the moment this is availability, way less than a minute. yeah, of downtime. Yeah, so we can't even figure out that something's wrong. Yeah, so not making any better. But what we can do is, since availability is not just the failover time, how long it takes to failover, is also can we preserve all the data. Now we're working on actually protecting the data. So we have 2 copies in the primary data center. We have 1 copy in the high availability data center, and the next slide will explain how far they are apart from each other. But primary and AJ are relatively close to each other, and DR is far away. So we have 3 synchronous copies of the data, and then 1 async copy on the DR side, which is great. But what if the primary fails and we have to run in the high availability data center for a longer time? We don't have a synchronous copy of the data there, so we need to add another machine there, and we have to add another machine in the DR data center. If we run all the way on DR, we have this. Yeah? So to do the math again, now we have lots of 9s, and I don't even want to say them anymore. Yeah, it's lots of them. And in this case, either data center fails, I can make the other data center the new primary one and run there the same way I ran in the primary. Okay, so that helps us with all the failures of hardware. Yeah, OS crashes, SQL Server crashes, that's all great. That helps us there. But what if someone drops some data, deletes some data, drops a table, all these nice, nasty little errors. Yeah. For that, we would have to restore an old backup and then recover the data from there, which can take a long time, especially with large databases. Yeah. And what a trick that I used for a long time is to add another machine where I don't use availability groups, database mirroring to get the data there, but I use log shipping. And log shipping has one little feature built in that almost nobody uses. It's an option where you can say how much you want that log apply delayed, how many minutes. Yeah? So you're taking a log backup now, and normally with log shipping, you try to apply it as quickly as possible to the other side. But in our case, we don't want to apply it as quickly as possible. We want to apply it 4 hours from now. And 4 hours is a random number I picked out of my head. Yeah? This could be 6 hours, 8 hours, 24 hours, depending on your business. Usually where I work, we notice within 1 or 2 hours something's wrong. So if I have the data from 4 hours ago, tell everybody and it bubbles up down to the database team, the 1 hour since they noticed it is now like 2 to 3 hours. And I know that box, that little box here, still has that data unharmed. Yeah? All I have to do is figure out when did it actually happen that they dropped the data, restore the logs till like a second before that or a minute before that, and then I can salvage 99.9% of the data that's in there and make everybody happy again. So let me quickly clean that. How do I clean that? No. Pointer options.
Should be able to hit escape and it'll ask if you want. Oh, there you go. That's even better.
I just used a pen and the thing is, yeah. Okay, so we have these 4-hour delayed log shipping. And of course, in my crazy paranoia, I have to put one of these in each data center. So now we're at 9 machines. And since I'm super paranoid, I want to have like 2 chances in recovering that data. So I want one machine with 4 hours delay and another one with 6 hours. Yeah. And this is where it gets really crazy. Yeah. And I fully understand that this is not what normal people do. But if you want to have one of the most available systems that actually works in all cases, not just physical damage to your environment, but also human errors, this is what you have to build. And don't panic. A couple of slides later, we will make that into something affordable, yeah, because there's some awesome tricks you can do to make that less expensive. Yeah. So, because that would be 12 servers and 10 times the licensing fee, which no sane financial person in any company would ever approve, unless it's like really, really important data. But I've never seen a case that this got approved. But this is the theoretical model, what you have to build. And we go there. From there, you also need to take backups that go to some file share. which of course you need in each data center. And you want to have two of them just in case one of them goes broke. So you back up on Monday on the first one, on Tuesday on the second one, and then you alternate. Yeah? These are usually shared between all the database servers, and in some cases even other servers that need to put backups in some file shares. Yeah? And then of course you need long-term storage and put all this to tapes. And that's all great. And we've all seen taking backups and storing them on tapes, and then 3 years later, someone needs to restore, and then we figure out, oops, that doesn't work. So you need another file server somewhere where you can do test restores, and another SQL server where you can do some test restores. And then to satisfy the very, very last point, you need, besides disaster recovery, you need something I like to call the last resort. And the last resort is some other place that is not connected to your data centers in any form, size, or shape, where you have an additional backup of your data. Yeah? This can be you put it in your office, you put it in the basement of the owner of the company. Yeah? Not very great places, but thing is, and there's professional companies that actually sell like old mining shafts where you can bring down the data and store it there, inside mountains and all this. Great things you can do. Yeah. So all this is basically between the primary, in the primary data center, you work with an AG. You also use an AG to the HAD disaster AJ data center. Thing is, you will build an AG in the DR side and then connect the two with a distributed AG that is async. So that allows you to fail over between the primary and DHA data center, and the DR will be automatically fed from either one of them. And if both of them fail, you can go to DR. And the trick that is used here is, I will explain on the next slide. And the log shipping takes the log back up to one of the file servers and restores it with a delay on your local site, and then copies it to the next file server in the next data center and restores it from there, and then does the same in the third one. And with that, you actually test your backups that they are good. And then you have these delayed ones, and your transaction log backups are tested in the same way. Yeah? So this is the scenario, the theoretical one. Again, nobody will ever approve that from a cost perspective, but this is what you have to put in your documentation, and then let the CFO make the decision. No, we're not spending that much money. Then, because 3 years from now, when something happens, you can say, I told you we need this. And you said we don't need it. So don't fire me, fire yourself. They will still fire you, but at least you have the satisfaction of telling them, I told you so. So how to place the data centers or the data itself. We have the primary data center, and we have our high availability data center. And they are connected, and they should be within what I call 1 millisecond. Yeah, so less than 150 kilometers apart, or 93 US miles. They are very close together. And that is great because we can synchronous replicate data between them without too much overhead. And 1 millisecond is pretty good. And usually they are even closer. So in one practical case, they were all about 30 miles air distance, 40 miles actual cable length apart. And that gives you like half a millisecond. And that's really good. Yeah? Because that is almost not noticeable when you do availability groups. Yeah, you notice it, but almost not. Yeah, and then there's the DR data center that should be at least 500 miles or 800 kilometers apart. Yeah, and in a different environment. So if your primary data centers are somewhere in a coastal area, don't put the DR data center down on the same coast, because if a storm comes in and hits the coast in a bad angle, they all might be affected. Yeah. So if your primary data center is on the coast, put the DR in the desert. Yeah. So tornadoes and everything will endanger you there, and floods will endanger you in the other area. Yeah. It's simple common sense. Yeah? And then your last resort, the little bunker in the mountain, as far, far away as you can legally have it. Yeah? Store the freaking tapes in Alaska. Yeah? If you're in the continental USA, ship them to Hawaii. Yeah? You have your data centers in Chicago and Seattle. Put the tapes to Florida. Yeah? Or Texas, something. Yeah? Just move them as far away. So, and the trick is, you have synchronous communication here. So whatever you write here immediately comes down here. Yeah? And this is hanging behind. It doesn't have all the data. So what happens now is that the moment your primary data center fails for whatever reason, you configure the system to make that synchronous. That will slow you down massively, but will ensure that both data centers have all the data current. Yeah. Now you're running slower, but you're still running without any possible data loss. And this is, again, you have to make a compromise what is there. Yeah. This comes back up the primary data center, you can go back to normal operation. Yeah. If not, if this is an event that now hits the second data center as well, let's say the primary ones are both at the coast, storm hits first here and then hits here as well. Now you have still all the data up and running and concurrent in your DR website, DR data center. And that's the trick. So you're basically using the HA data center as your buffer. Yeah, the primary fails thing is. Yeah. Same goes if the HA data center gets blown out first. The primary is now alone. It gets reconfigured, makes that the synchronous one. It runs slower, but we have at least a chance of recovering all the data. This is if losing data is the higher priority over performance. And every SLA must have defined that. What's more important? Do I rather have 10 customers per second and don't lose data, or do I want to have 50 customers per second and the possibility that half of the data is gone at the end? Yeah? It's something that the SLA has to specify, and then you can engineer a solution to it. If the SLA doesn't tell you what to do, you can guess, but we know guessing is a dangerous trade in our things. So what's the practical availability if we encounter all that? When you include planned outages, yeah, maintenance and all that, with multiple machines and the way to failover and all these jazz, I would not guarantee more than 99.7%. That's pretty much 1 day per year. I need the systems down for whatever reason. Is it patching, anything else? Things I cannot do in the background. Yeah. And unplanned failures are considered in here. Yeah. If I only go for unplanned and say everything I plan and announce upfront that will cause an outage doesn't count as the systems are down, and then I'm willing to immediately go up and move that to 99.9, not any higher. You can convince me to go to 99.5 if the company has a 24/7 NOC, Network Operations Center, where there's people on site all day long, every day of the year, and they have training and they can immediately deal with a situation if something arises. Yeah. Because you can build automatic failover as much as you want. There's always cases where it doesn't work for whatever reason. Something needs to be turned off for the failover to actually happen. Something needs to be turned on. Something needs a little extra nudge to get running. Give me 1 second. So all that said, I have a SQL Server that I turned on in 2007, and nobody has turned it off since then, and it's running in production every day since then. It's completely isolated. It doesn't need patching because otherwise it would be down. Yeah? This machine hasn't stopped working since 2007. It's now in its 13th year of operation. It never had a power outage. It never needed to move. It's still running, never failed, not a fan, not a power supply, not a single hard drive failed. It's just running for 13 years straight at 100%. But remember one of my very first slides. This has nothing to do with magic engineering. This is pure luck. Yeah, this machine was turned on, and we got super lucky. At any point in time, that machine can explode. That machine is so old, it runs a beta version of SQL Server 2008. So if it ever actually stops, it will never come back online because the time bomb that Microsoft put in to not be able to start the service expired into early 2008. Yeah. So even if that for any reason would have stopped at any point in time in between, it would not run anymore because the time bomb gets checked every time the service starts. So this is really interesting. So now we're getting reasonable. We've built a theoretical system that we will never get the budget for. So how can we make that reasonable? You remember my cheap machines. They had CPU, network cards, and direct attached storage. They come in bigger boxes than you actually need in most cases. So the smallest machine I built, and that can be the base for virtualization, or that can be actual physical boxes. It's basically the same. Yeah. Somewhere between 20 and 56 core, depending on how much CPU power I need and how the licensing goes. I immediately put in the maximum amount of memory because there is no savings there. It doesn't cost more if on licensing, if I put it all in, and it really helps SQL Server to thrive. And then the bare minimum is 32 terabytes of storage. Yeah, that's four 8 terabyte NVMe drives, and each one of them can do about 3 gigabytes per second on I/O. Right? And that's a small box. And these boxes cost between $45,000 and $50,000. That's with the memory, and that's with the 32 terabytes of super fast storage. Yeah? And a total of 100 gigabit network card. I can take the same box and put 4 times as much storage into it. And again, same number of cores, same number of megabyte. And the price 45 is with 20 cores and 50 is with 56 cores. So that's a difference in pricing. And that recently happened since AMD made awesome chips. Intel had to lower their chip prices. If instead of 32 terabytes, I put in 128 terabytes of storage, which is 4 times as much, it costs between $64,000 and $69,000. Yeah. Any SAN storage with 128 terabytes costs in the hundreds of thousands of dollars alone. Yeah. So having this more storage is basically, it's not free, but it costs very, very little. Yeah. And it will allow us to do an awesome trick. So we remember our 12 servers, 10 licenses that we need. Let's see if we can beat that. We have a primary as before, and we have another primary for another database. Yeah, because it's very rare that you just have one database. Yeah, you have multiple. In most companies, have like dozens of production machines, the larger ones. Yeah, we have our HA copies in the same data center, and then the log shipping we can put all on one machine. We had why? Because we now, this machine is where we put one with 4 times as much storage in. Yeah, so this is easy. And then in the high availability data center, where we actually never plan on going actually online for a long time, we only need a pair of machines because the upper machine can hold a copy of the data from the lower machine and the other way around. So what we're doing basically right now is we're copying the data like this. They're both copying the data here, yeah, but they also both copying here, and then they copy it up and down. Yeah. So yes, and we basically do the same trick on the DR side. Copy again, and then up and down, and then we also have both log shipping copies over here. Yeah. So this allows us to reduce a lot of that number of machines. Yeah? So because we went down 2 per server, 5 machines. 1, 2, 3, 4, half is 5. and we only need 3 licenses. 1 license, 2 license. This one is free. This one is free. We need a third one here. Yeah? So we need a total of 1, 2, 3, 4, 5 licenses. The DR and AJ are free. So I have 6 licenses in total. Half of that is 3 per machines. So for each one of these machines, we have now an average of 5 machines per database with 3 licenses. Let's see if we can improve that even more. Let me clean up. And let's continue with the next one. So what if we had 4 database servers to begin with? Yeah? Then we could say we only have 2 high availability copies. Same here, just 2 in the AJ data center, 2 in the DR, and we add the 2 log shippers. Okay? And same as before, this one goes here, this one goes here, same down here. Then the log shipping of all 4 goes to the same, yeah, because they have a thing. Yeah. In the AJ data center, we move both here, then we move them both up, we move them both down. Yeah. So here I have 4x, here I have 4 times the data, here I have 2x the data, here I have 1x the data. Yeah. And then exactly the same thing in the DR side. Yeah. And then again, all 4 log shipping. So 4x, 4x, and 4x. Yeah. If I add all that up, I have an average on 3 servers per database with 2.25 licenses. And if you're employed by Microsoft and you're listening right now, cover your ears. If you negotiate with Microsoft and you put DR in the cloud, you get down to 1.25 licenses. That's how good you can become. Yeah, because you can negotiate that. You can use some credits in the cloud and all that, and gets you down a little bit here from a licensing perspective. Yeah. Even on-prem, you can negotiate to below 2 licenses per installation. Yeah. And all that changed a lot with 2019. Yeah. So again, let me clean my awesome drawings here. Oop. So to illustrate that, we have regular AGs between the AJ and the primary and the second machine on the primary side. We do the additional AG down to the second machine on the AJ side. We have an AG between on the DR side, and we put a distributed AG between them. And the log shipping goes to all machines. And then each one of the additional machines just reuses the existing machines to a certain degree. Yeah. So this is how you can lower your budget and things. And that you have 4 primary database servers is not that uncommon. Yeah. And then if you place your machines in a clever way, you have that. Yes, if you run in the DR data center, you are at less capacity, but there's a big chance that this is acceptable. Yeah? And again, that's part that has to be in the SLA, that during DR, you only have half the compute power. Yeah? And again, the chances that you actually have to go to the DR data center is very, very low. Yeah? So everything is a compromise, and we reduce the risk till it becomes acceptable. Yeah? You can never get rid of all the risk, but you can get very, very close to what you need to do. For the very last slide, I put together a nice little table. When you look at all the AJDR options that you have on the side here, you have backup, restore, log shipping, failover clustering, mirroring, always on without the space in 2012, always on with a space in 2014 and later. Thing is, and then you have, can you implement zero data loss? And the reason this area here is orange is because you can implement zero data loss with these versions of SQL Server if the primary dies first. If the secondary machine dies first, you have a chance of data loss. This is why it's orange. Thing is, yeah. Can you have zero data loss at the same time as you have AJ and DR? So can you have zero data loss into AJ and DR? The starting with 2017, not before. Can you have automatic failover? Yes. Not for backup and log shipping, but for all the others, you can. Can you have automatic HA and automatic DR? Only 2016 and later with always on. For all the other technologies, you might be able to script something, but it's not built in. Can you have faster recovery of long-running transaction? It's a new feature in 2019. Advanced database recovery, even rollbacks that took days before can now take seconds. It comes at a price. Your transaction log will be hit harder, but since we already decided that we go to the cheap and fast machines, that's actually not an issue. None of these high availability features except backup and log shipping can protect you from accidentally dropping, deleting, or overwriting data, because their job is to move that change as fast as possible to all the other machines. And the last column is which one of these technologies actually support distributed transactions. That's a very short list that is always on since 2016. And failover clustering, backup and restore, mirroring, and always on in the early days did not support distributed transaction. Doesn't mean it didn't work. It just meant if you actually fail over, there's a chance of a ghost record that doesn't get rolled back correctly. Yeah? And then you have additional data somewhere that you have to manually delete, but yeah, wasn't supported. In the latest versions, it is. So this is more like a, you need to have a quick look at what it is. What I normally do is I'll take these and combine it with this, and that gives me all the green here, plus the green over here. Yeah? And that gives me the whole shenanigans across the board. And that is the awesomeness. And I just found out if I tip the screen with the back of my pen, it deletes. That's awesome. So that gives me the combination I need, and this is what we're working for. You need all the features and things. And yes, there's tons of other features that might or might not work with something like a replication and the file stream and in-memory OLTP and all that has limitations, but this is the basics. I mean, this is a topic we could talk a whole like week in a nice conference or training setting. But anyways, so this is it. I don't know how questions work here right now. If David already collected a bunch, or if we've now open up the mics and people can ask them. Thank you very much. And here is my email address. If you don't want to ask the question in public, you can email me, and I will try to get back to you as quickly as possible. Thank you very much.
Sweet. Thank you. That was amazing. I can say you have actually answered the questions that we had in flight quite by accident. So if there's any other questions out there, please, now is the time, or to send them an email directly.
Yep.
Yeah, and I can tell you from a real world experience, it doesn't get any more real world than what you just heard. For everybody out there, these are the things that you really have to worry about, because in the event that the worst case scenario happens, you are the first lifeblood of the business. So
yeah, the DBAs are the last line of defense. Usually after the DBA, there's usually the data center team and the sysadmins, but they don't see it as their job to protect anything. Yeah, they will rebuild, but their mindset is not wrapped around protecting it. The database team is the last line of defense when it comes to let's not lose the data. Yeah. Yeah. If we don't insist on good backups, on good tape management, yeah, nobody cares, because in the application world, nobody cares. It's, yeah, you redeploy the software, you download the program again, you just install it, and everything's fine again. Yeah, yeah, I can do the same thing with SQL Server. I just download it again, install it on a new box, but then, yeah, where's the data from the database going? Yeah?
Exactly.
And yeah, and don't get me wrong, I had once a case where we were fighting for like hours to recover a database, And then we finally got around to the application team, and they're like, yeah, if you just give us an empty shell, we're fine. Like, you could have told us this 8 hours ago. Yeah. Yeah. All they needed was, because they like, yeah, you recovered at all the database, and then we figure out the data next week. Yeah. This is more like a logging facility where we didn't know. Yeah. And this is why it's so important to have an SLA that manages all that, so that when it comes to a real outage, the DBAs just open the book and like, oh, they actually don't need the data right now. I can create them an empty database with that creation script, and they're back online in 5 minutes. And then I deal with things. It's all about not over engineering. Yeah, I fully understand the thing in the middle I presented. Yeah, is insanely over engineered, and not even I, with my crazy jobs, have ever built it in that size. Yeah, but it's, if they want a solution that covers all their wish list, that's what it is. Yeah. And then let's compromise till the risk is acceptable versus the cost. Because where's the point if your data is worth $100,000 and you're spending 20 million to protect it? Yeah, no point. Yeah. On the other hand, if your data is worth $1 billion and you need $1 million to protect it, yeah, that's worth the investment. Yeah.
Exactly. Do have one good question here. What if the network or internet connection between the primary and the HA site were to fail?
So, going back is slower than going forward. Almost there. Yeah, here we go. So this is why this is this nice little triangle. And let me, they should make this like a, so this is why you see that I have two connections here. You have to have this triangle. Yeah. So you basically have three connections to make that 100% work. Yeah. Ideally, they are from three different carriers, so that you're not depending on a carrier. But at least number 1 and 2 in this thing now have to be from different carriers. Yeah? And that's usually easily available because carriers actually partner up with that. So we had one line that we needed, one of these DR lines that need to go down the coast. And one was going through New York, and the other one was going through going all the way up to Chicago, and then going to the West Coast there. So one went into New York and to the other coast, and the other one went up to Chicago and then to the coast. So if they're both dead, yeah, there's nothing you can do. But normally, if they are like separated and they start at 150 or 90 miles apart, and then the actual practical routing would, perfect routing would be like this for the bottom one. Yeah, go into the data center from the other side, never come close. And believe me, this is how data centers built. If you go into a professional data center, they will have one carrier on the west end on the building, and they have the other carrier on the other side. Same goes with power utility lines. They know how to do that. Yeah, this were rookie mistakes made 20 years ago. This is no longer the case. Any professional data center these days, they learned a lesson because they had the famous caterpillar that hit the lines. Yeah, and then they dug the second trench on the other side of the building. It's not rocket science, but this is how you would practically do it, and it would be two different carriers. Then it's not. Yeah, and they guarantee that because sometimes carriers share lines. So you might have a crazy setup where this goes like this and then runs on the same line for a while and comes back down. You have to avoid that. Yeah, and there's literally carriers that says, yes, we don't share any lines with this carrier in this area. We don't share anything with this guy in this area, and then they can actually give you what you need.
Perfect. I think that's all the questions.
Cool. Thank you very much.
Excellent.
And
So thank you, thank you, thank you, thank you.
I will
Thanks to everybody who, or go ahead, sorry.
I will send the slides so you can share them.
Perfect. I'll get that up on the site here within the next 24 hours. I will have the recording for this posted as soon as humanly possible, so as soon as the site allows me to do the upload and processes it. And if you're watching this after the fact, you've got his direct email. Shoot him an email whenever you can. Quite
Mhm.
honestly, say thanks. A lot of us just we do this because we care. We want to know that this has helped somebody. So even just a simple thank you is always appreciated. TG, thank you.
That's a
Thanks
slide
for
to
every.
David. They're not up and for download. It's not my fault anymore.
Exactly. Cool. So thank you all for watching. Thank you all for taking the time out of your day. I really appreciate it. And we look forward to having everybody here at the next one.
Mhm. Thank you. Bye. So.